Let's assume we have an object right here. An object, let's say a car. And this car wants to go from, again, point A and go, let's assume the driver wants to go back home after a long day of work. Right, this is the house. And the distance from the starting position of the car, let's say he's coming back from work. Again, this is a tower. He's going back home. Now, the distance from his house, let's assume is, let me do a better one. Let's assume that the distance from his house is 10 meters. 10 meters, or actually, that's not too realistic. Let's go with kilometers. And we know that the driver, assuming that he's a safe driver, the driver has a speed limit of 50 kilometers an hour. And that's in kilometers. Now, obviously, we have a radar here. We have a radar here. Now, the driver doesn't want to get a fine because he'll have to pay a fine. He'll have to pay for the ticket that he'll get. And he doesn't have the money, right? And he needs to go from his office to his house, maintaining a speed limit of 50 kilometers an hour so he doesn't get flashed by the radar. And the last thing we want is him getting flashed by the radar. Because if he does, he'll have to pay a fine, and he doesn't want to pay a fine. Now, he needs to get home urgently, right? He needs to get home urgently. But he calls his wife, right? He calls his wife and he tells her, "What are you cooking for dinner?" And his wife says, "I'm not cooking. I'm going to order some KFC." Well, how long do you need to get home? Because I know that the app is telling me that the KFC driver needs an hour to get home. So we can denote here that the time for K, and K is for KFC, is an hour. 1 hour. So the time for the KFC to arrive would be 1 hour. And the wife is asking her husband, "How long do you need to get home?" Because she wants the time. She wants the KFC driver and her husband to arrive at the same time so the food is warm. So the husband looks up on Google Maps and puts in his house address, and then he ends up getting a time. And that's what we're going to look at to see how long did Google Maps tell him he's going to get home. Now remember, we have several factors, and this is where I'm going to introduce something known as SUVAT. SUVAT basically stands for S stands for displacement or distance, and U is the initial velocity, V is the final velocity. So V is the final velocity, A is acceleration, and T is time. So this is time in seconds, obviously. This is acceleration, and that's in meter per second. That's not supposed to be a minus. Meter per second. Then we have velocity, that's final velocity. Then we have initial. And this is displacement. Obviously, this is in meter per second inverse second inverse 1. Meters. And you can also consider distance, but for now we're going to consider displacement. Now, actually no, well, you can only consider displacement in this case. Now, again, back to the story, we need to know how long it's going to take him to get home, considering that he's following the speed limit, and is he going to get home on time when the KFC arrives? Like, who doesn't like fried chicken these days? I do. So I bought my mom an air fryer, so at least we can cook a healthy fried chicken. So in this case, we're going to look at um, several equations that you need to know when we're dealing with motion. So the first one is V is equal to U plus AT. The other one is S is equal to U plus half AT squared. Then we have V squared is equal to U squared plus S. And the last but not least is S is equal to half of V plus U. And that will give you, and these are the equations of motion that you need to know for when we're dealing with motion. When we're trying to analyze motion, this is what you're going to need to know. So let's go ahead and get into work. I will keep this here, and we are going to focus on trying to see how long it's going to take him to get home. So again, I'm going to erase all of this, but I'm going to keep the suva because I also want to discuss something. Now, whenever you're dealing with motion, it would be nice to actually draw this out like this. There's a reason why I didn't do it as that. Like this. I didn't do it horizontally, I did it vertically because it will help you right now with this. Now, the total displacement from the starting position, which is from the office to the home, is 10 kilometers. So we're going to go ahead and write 10. Actually, I'll put in blue if you guys can red. 10 kilometers. And we know that 1 kilometer, I'll put it here, 1 kilometer is equal to 1,000 meters. So that would be 10,000. U, again, he's just started, so we can assume that he's starting from rest. V, we know his final velocity before he parks is going to be 50. Per second and verse 1. And obviously acceleration. Now here's the thing. He's going to drive at a constant velocity of 50 meters. He doesn't want to get a fine, but at the same time he doesn't want to be late. So he's going to drive 50 kilometers an hour. I made a mistake here. That should be kilometers, kilometer per hour. Hour in verse 1. Hour in verse 1. And acceleration, again, we said it will be 0. Actually, we're not going to include acceleration here because it's not given. So we can disregard A at this point. And then T is what we want to find. I'll always just put a star because t is what we're trying to find. So we're going to disregard this for now. Now, I have my displacement. I have the initial. I have the final velocity. I want to find time. What can I use to go back? And I'll actually put this up so I have all of these. Now, let's look at the first one. So we have final velocity. That's given. Initial is given. Acceleration is not given, so we can disregard this. We also have acceleration here, so I'm going to have to disregard this one as well. However, I do have v squared is equal to u squared, but we still have the a, so we can't use that. But I do have equation because it doesn't consider time. It doesn't consider acceleration. Therefore, I'm going to go ahead and these and just take this one into account. I'll just rewrite it here. So S is equal to half plus U. Alright. So right now, I'm going to go ahead and consider this equation. So I'll write on the top. We'll consider this equation and we'll substitute the values we have. So S is equal to half of V plus U T. Now, I do want to keep one thing in mind. We are dealing with, let's say, a weird quantity here. So we're dealing with kilometers, we're dealing with hours. In physics, usually you're dealing with SI units, so the standardized international quantities, and the standard quantity should be, as I mentioned, meters per second inverse 1 for velocity, meters for displacement or distance, meter per second squared for acceleration, and obviously seconds for time. But because we have a lot of kilometers, if we take a look, we have an hour for the KFC to arrive, as we see here, an hour for the KFC to arrive. Our distance is 1 kilometer, 10 kilometers from point A to point B. Our variables for speed, velocity is in kilometers an hour. So theoretically, if you're stuck in a situation like this, and this is something that I intentionally had prepared for you, you can actually give your time, calculate using these variables, and then multiply your hours by 3600 to get the time in seconds. But then time in seconds is going to be way too huge, and you don't want to tell your wife the time that you're going to get home in seconds. Your wife's going to be like, oh, who cares? I'm not going to do the math. Just tell me how long you need to get home in hours. Don't tell me in seconds. And that's what we're going to do here. So again, we can disregard this for now, and we're going to say, okay, we have a distance of 10 kilometers, half, and then final velocity is 50, still is 0, and t is what I want to find. So that'll be 10, and then half of 50 is just 25, t. And now if I want to substitute to find t, it's simply 10 over 25 is equal to t, and 10 over 25, that should give us 0.4 equal to t, but hold on, where it should be 0.4 hours to the time. Now we we know that 1 hour is equal to 60 minutes. And obviously, you're not gonna think, "Hey, wife, I'm gonna be there in 0.4 hours." Your wife probably will want to kill you if you say that. So you just go ahead and say 0.4 times 60 because we want to convert that to minutes, and 0.4 times 60 should be, let's see here, 24. You're gonna need 24 minutes to get home. Now, obviously, your wife is gonna freak out because, oh my god, my husband's gonna mess up the whole house because he's gonna be here in approximately half an hour, or let's in this case say 24 minutes, and for the other half an hour, he's gonna keep wandering around the house, dirtying it all up after I cleaned it. So she will have to call the KFC and ask, "Can you guys get in early? I need to place an order. Please get in here early," and they'll need an hour. So therefore, the husband wins. Everyone wins, and um, the husband gets in the house in 24 minutes. Now, I do want to discuss one thing of a proportion here. I'm not being sexist if what's it called? If you guys are assaulted in any way, that's really just real life applications here, and that's actually what you need for an IB. That's what you need for IB to get a 5. You need to be able to apply your knowledge in real life situations. Now, I will be discussing an intro to my next class, which is projectile motions. And projectiles motion basically is we're going to be dealing with assuming that if we have an object that's thrown at an angle in respect to the x-axis or the y-axis, and we're going to be looking at what is the maximum height achieved here, or what is the distance between the starting position and ending position of the ball. If I throw a ball from this position at an angle here, how long will it fly? Uh, is how long will it be in the air for the time? So we will be discussing these in my next lesson. Hopefully, um, this lesson's been helpful for you. Please check out Discord updates for any new announcements, and good luck with your exams. And if you have any questions, please feel free to send them down in the chat.